Am I audible? Check it now. Okay, thank you. संदीप, तुला पण को ऑर्गनायझर केले हा. तू पण ऍड करू शकतो बघ. हा हा ठीक आहे. Okay, good evening all. Welcome back to the training program of data mining using WEKA tool. So this is our third day, and in this third day, we will see the classification algorithms along with their practicals, applications of classifications, and the uh, practicals and the theory of classification algorithms. Fine. So give me only 2 minutes because some are joining now. I hope I am audible to all. Thank you so much. Just enable my mic. Okay. So good evening once again. So today in this session, we are going to see the concepts of classification algorithms, machine learning classification algorithms, theoretically as well as practically. Fine. Let me share my screen. So here you can see our third session, and the task about this third session is to classify some data according to some of the models, and then we will find out some classes through the data and through the design develop models. Fine. So today is our third session, right? In this third day, we will see classification task. So WEKA is also giving all type of algorithms of machine learning, ensemble learning, then clustering also. These algorithms are very useful for our daily life because whatever data we are generating accordingly, these models of data mining, or you can say the machine learnings, can classify the contents. Okay, so this is the particular slide where contents of today's session have been mentioned. Overview of algorithms, the classification, exactly what is then the algorithms, and then we will build evaluate models, then we will create some classifiers using the data, and then we will try to evaluate those classifiers. Okay, so theoretically, practically, we will see all those tasks. Fine. Now you can see here what is exactly classification is. Classification is very simple. Classification is saying that arrange the data into systematic format. Okay, so whatever attributes are there in a yesterday's session, we have seen the attributes, or you can say attributes or instances or records. Fine. And according to the attributes, according to the characteristics of attributes, we can categorize, we can classify some contents. Okay, so that is you can say the classification. Whatever task we are having, whatever data we are having, according to the data and according to the task, we can classify the data sets. Fine. Means, for example, we have two categories, male and female. Based on the characteristics of male and female, we can categorize it. Okay, so that is why classification is important. Based on the particular category, based on the particular property of the data, we can classify the content. So simply here, one formal definition have been written here: the action of classifying or arranging the classes according to the common characteristics or infinites assignment to the proper class. It's very simple. It is one of the systematic way to classify or arrange the classes according to their features, according to their properties or characteristics. Fine. So that is nothing but the classification. So in a machine learning, there are two major categories of classification. Not only two, but three are there. First one is supervised classification. Supervised classification. Second one is the unsupervised classification. Okay, okay. And third one is the hybrid classification. Hybrid classification. So according to this, our models can be developed and it can be designed. Fine. So some are having screen is not visible. Am I audible? Can anyone put the message? Am I audible? So I'm sharing the screen here. Now I hope so my screen is visible to all. Okay. So thank you for the clarification. Now, see, as mentioned that classification can be one of the tasks to arrange our data, to arrange the properties, to arrange the classes according to the characteristics of that particular data. Okay, so here one diagram is given. Let's consider we have the input data. Yesterday only we have seen some data sets, right? So here we'll require some data. According to the data, we can classify the data. So here classification model is required. So we can build the classification model in this second step, and according to the classification, we will get some output in the form of some labels. Okay, classification output to check what type of category we are having, right? So according to that information, we can have the category. Fine. So you can see this particular model here for predicting the worthiness. Before it, so in the left side, you can see it is finding a model for class attribute as a function of the values of the other attributes. Fine. Means simply I have data and I have to categorize some values. I have to classify the values from that data, not only text values but also image values, video values also we can classify. But as discussed, WEKA supports to the text data as well as image data if you have the plugin, right, of that image processing, right? So this diagram can be frequently used in data mining or in a machine learning when we talk about the classification. Fine. Classification is simply saying that whatever values you are having, whatever columns you are having, according to the columns, okay, columns are nothing but our attributes. So there we are having some properties. According to those property, just organize, just classify the data. Okay, so that is classification in a simple term. Now see this particular second diagram. Here you can have the model for predicting the credit worthiness. Okay, so we have to check from the data. This is the data, employed data. Fine. So 4 to 5 employees have been given. Yes, yes, no, yes. Their employed characteristics are yes, yes, no, no for this particular attribute. Level of education is our second attribute because this is one of the column, and these rows are nothing but the instances with respect to the column, with respect to the attribute, with respect to the feature. Fine. So here level of education for the first employee is a graduate. He is the graduate. Second one is high school wala. Third one is undergraduate, and last one is a high school again. So these are the properties of those employees with respect to their education. Now, years at the present address. So how many years are there? Uh, they are employed with that particular company or that organization. So first one is present from last 5 years in that organization. Second one is for 2 years, 1 year, 10 year accordingly. Now last category, last column as mentioned in our .csv data. Okay, whenever you try to load any CSV data or the text data, you can see last column always having the categories, classes you can say, not a category, classes. Categories can become under the clustering. Okay, so in last column, we can have the classes. So here only two classes are there. First one, yes, credit worthy, yes, no, no, yes. Based on these particular three columns, one, two, three, we have to find out the output of the employees. Okay, so here employed, no, yes, but here only one employee employed is not there, so that is why only one. Then the second category, yes, if yes, education. Education, how many graduates are there? So here we have categorized as per the graduate and then the high school undergraduate, either graduate or undergraduate. So you can see number of years graduate are greater than 3 year, less than 3 year. Some are yes, some are no. And here number of years as per the high school, greater than 7 years, they are yes, and less than 7 years, no. So these type of categories, these type of predictions are there. Okay, so according to this type of prediction, we can finally categorize that the employee is having the credit of worthy or no. Fine. So in this task, we will require some mathematics as discussed mentioned in our first session only. Data mining requires statistics. In some cases, mathematics if you are trying to apply the machine learning, and then the neural network or deep learning. Fine. So here statistics for classification purposes we will require, and then the mathematics also. So mathematical models we can develop, and then we can get our output. Fine. Now see classification example. In this slide, you can see we have some data, and according to the data we can build such type of model, right? But how can I do? So here information about the employee are yes, yes, no, yes. So categorical information is there. This is also categorical information, that is nominal information, right? So it is not a number, it is one of the category. Nominal, you can say we have yesterday converted numbers into nominal and nominal into numbers, right? So that type of category is there for the first two columns. Third column is a numeric column, that is quantitative, because here we are having some values. Okay, so values, if values are there, so it can be like a minimum, maximum value, mean, standard deviation. That can be the outcome of this particular column. Fine. So this is my training data. Now, before developing any model, machine learning model, we will require some training data. Let's consider here total employees are there. How many total? For example, 100 total employees are there. Okay. And from 100, not 100, because here only four values are there. We will see like a eight employees are there. Only 8 employees are there, because here we are choosing giving the training with only four employees, right? That is why I have given sample space. I mean the complete data size, that is 8. Okay, means in the data 8 instances, 8 records are there. So some of the records we can give for the training purposes. Okay, so here that data we can use as a training set. Fine. And according to the training, whatever training we are giving, the model can learn the characteristics of that data, of that attribute. Okay, so here learn classifier, and we are applying the training set. That means trainer is required. Fine. Trainer is required in the sense here which algorithm I can apply here. We can apply the supervised algorithm. So you can see here two major categories of classification are supervised, unsupervised, and hybrid. So from these three, we are applying the supervise. Why? Because supervise means supervisor is there to train the data. Like just now, I am giving some demo to you. That means I am just training to you, right? So that means a supervised algorithm we are applying here, and accordingly you are getting some output. Fine. So here supervised approach are used whenever we are having known data. Means from this data, if you are having the knowledge of the characteristics of columns, then knowledge about the instances, then in that case we can apply the supervised learning. That is the general formula, or you can say the general properties of a supervised classification. Okay, that means supervised apply is used here, and accordingly training set is given. So training set here, let's consider only four training set samples have been given, and according to the training set, how many values we have given to the training set? Four values. So according to that, classifier will learn the model. Okay, classifier will learn from the model. Whatever model we are generating, that model, that classifier can take a training data, and then it will learn from that data, and we can get the final model. Okay, so here is the model. Means according to the training data, whatever algorithm we are trying to apply, so that algorithm will learn the data, and accordingly we can create the machine learning model here. Okay, now our model is ready. I have to test the other values, because as mentioned here, how many values are there in my data? 8 values are there. Remaining 8, remaining 4 I have to test through this newly generated model. Getting my point? For from this data, some of the value we have given for the training set, and the model has trained, and accordingly now we are giving some of the other information, some of the other values. You can see now here the information is a different number of years, 7 3 2. Here 7 is not present, 3 is not present. Okay, only 2 is there, but so this 2 is for other person, right? So high school, yes, and we have to find out this last one. Here in this particular set we have given yes or no for training purposes. If employee is a graduate having 5 years of experience, then credit is worthy. If employee is a high school having the degree of high school, number of years of experience is a 2 year, then credit worthy is a no. So likewise, now we have to find out whether the employee can get the credit. Okay, so we can apply the remaining values from the data to the model, and then laterally we can get the output in the form of yes or no, because in this particular column only two classes are there, yes or no. These are the two classes. Okay, so that is the simple story of classification. Now examples, for example, classifying credit card transactions as per the legitimate or fraudulent. Okay, I want to, for example, classify the credit card and their transactions. Okay, and I have to check fraud credit transactions. Okay, so credit card transaction and fraudulent we can classify through the classification task. Then classifying land cover data, land cover information. So here one image is given. This is the general scenario of classification. For example, here some of the properties are there. One is some crops are present here. Here barren land is there, right? Here also barren land is there. But see the difference between these two. There is some difference. Here fourth attribute is the trees, and here fifth one is a roof or building you can say, and here again there is a barren land. So broadly here six different attributes are there in this data, and I have to classify these all six categories. So there, in this case also, classification can be done. So land cover patterns we can classify, like water bodies we can classify how many area is covered by the water bodies, how many area is covered by the urban area, forest area, barren land, how many buildings are there in the city. We can classify through the classification task. Again, categorizing the news stories. Okay, whether the story is related to the finance, whether the story is related to the weather, entertainment, sports, or minimum, or politics. What type of stories are there? According to the given input, we can classify that story, identifying the intruders in the cyberspace. Yeah, cyberspace, those who are working in the cloud area, in that case, we have to manage too many cloud information, right? And there, giving the security to the cloud data or our digital data, internet-based data is essential. In that case, some intruders will attack on the data, fine, and accordingly, the organizer need to be identified those intruders, or you can say simply the attackers who are trying to attack on the data. So in this case also algorithms of classification are used. It can be supervised, unsupervised, or hybrid. Okay, as per the data it can be changed. Then predicting the tumor cells, whether the person is having tumor, brain tumor or not, right? Likewise, we can classify their categories according to the given sample data. Here, CT scan images are used, classifying secondary structure of protein as a alpha helix, beta sheet, random coil, etc. So here, in a chemistry also, for classifying the different structure, we can use the classification. Okay. Now, what are the applications of a classification where I supposed to apply the classification algorithm? I will show you the practical about the classification. Don't worry about it. But just I'm giving the overview about what is exactly classification and why it is needed. Application first is a fraud detection. What type of fraud? Credit card fraud detection, or other type of fraud detection we can classify through the classification methods. Okay, so in this case, use credit card transaction and the information on its account holder as an attribute. So in a banking finance sector or in all type of transactions, we are using the credit cards, right? So the transaction is a fraud or not, that we have to classify. Okay, whether the person is doing fraud transactions or not doing the fraud transaction, that need to be classified. So here we will require the transaction information of the account holder. Okay, and then customer, whatever he is buying, try to buy, then what he is buying, how often he pays on time. So likewise, we can have the attribute characteristics. Okay, so in some cases, some people will simply use the information and information about the credit cards, and accordingly they will just take or some buy some products, and laterly they will not pay. Okay, so Likewise, transactions can be done by someone else. So in that case, based on their transaction history, based on their transaction details, we can classify it. So label the past transaction as a fraud or fair, and then classify the transactions. So labeling is required. Then learn a model for the class of the transaction. Okay, again apply the model, right? Means firstly give the training according to the labels of the first transaction, whether he is or she is doing fraud or fair transaction. Accordingly, the model will learn. And lastly, use the model to detect the fraud by observing the credit card transactions on the given account. So likewise, in banking sectors for checking the credit card transactions, we can apply the classification algorithms. Second is churn prediction for telephone customer. So in this case also to predict whether a customer is likely to be lost the competitor or not. So accordingly, the information like a detail of transaction with each of the past and present customers can be used, and accordingly a label can be given whether he is loyal or disloyal, and finally we can find out the loyalty, and then we can predict the churn, right? So here also we can use sky survey categories to predict the star or galaxy, है ना? Uh, or to predict the other information through sky survey cataloging. So in this case, some of the images we can use, okay, and then we can apply the classification model. And here some of the steps we can follow, and then we can get the output like whether it is a star or galaxy or other planets. Okay, means in these are the only three applications. There are too many applications, so that is continued with this slide. How many stars are there? How many galaxies are there? How many uh, planets are there? So classifying galaxy also, intermediate, early, late. So that can be again the sub classification about the galaxies, image features, the characteristics like a wave, then the light, etc., can be used, and then we can find out the objects. Okay, so only four to three applications we have seen, but for classification we have too many applications. Like for example, email spam email we have to identify or detect it. So there also classification algorithms are used. Okay, and if I want to check, identify the malicious activities, in that case also we can use the classification algorithms. And generally to classify the plant species, to classify the brain tumor, okay, patients through the brain tumor, okay, like whether he is having a tumor or not, then the uh, cancer prediction. So in all cases, medical imaging, medical healthcare sectors, agricultural sectors, right, banking sectors, educational sectors, whether I should take admission in that particular college or not. So that in that case also classification can be used. So those are the major application of classification. Now coming toward the last theoretical slide, algorithms about the classification, what type of classification algorithms we can have in the machine learning. Okay, so generally you can see the right side diagram, data mining paradigm. Right here, verification and discovery are the two major goals of data mining, and here we are looking for the discovery. Discovery means mining from the data. Mining means we are just trying to search some information. As mentioned in our first session, attribute mining, I mean a data mining, is mining the essential meaningful information from the data. So that is our category, that is discovering the information from the data. So here we can either describe it, and we can either predict the discovery, right? So whether the person will get some output or not. Okay, so likewise, if predictions are required, so in that case, for prediction purposes, either we can use classification or we can use the regression. So this regression is the a little bit part of statistics and used in machine learning also. Okay, so now I am not excluding here regression in this particular session because our target is to uh, identify the classes through the classification algorithm. So broadly, you can see here some of the classification algorithm, general classification algorithm like a neural network classification algorithm, Bayesian network classification algorithm, decision trees, support vector machine, instance based. Some of the classification algorithms have been mentioned here. So this particular diagram is the major paradigm diagram of data mining. So we are trying to discover something from the data with the prediction approach, and there we are trying to use the classification methods, and the classification methods are nothing but the support vector machine, decision trees, neural network, naive Bayes, and many more. Okay, now coming toward the right side diagram, you can see here for data mining some of the machine learning algorithms we are using. Okay, machine learning, which is a learning from the data. Okay, as discussed here, we are trying to learn from the data classification model. Okay, and here learn from the data, because here we are giving data as an input to the model. Okay, so that model will learn, means machine will learn from the data, and according to the learning from the data, it will give the prediction output or classification output, right? So that is why machine learning is used, because it is learning automatically from the given data, right? And it is giving the output as per the human behavior, right? So as I discussed, machine learning come under three major learning approaches, like supervised learning, unsupervised learning, and reinforcement learning. Fine. So machine learning algorithms learning in a three different ways. Even though we can have the hybrid learning also. Okay, or you can say semi supervised. Fine. Learning from either supervisor, learning from non-supervisor, learning from the reinforcement, or learning from the either supervised or unsupervised. So those four approaches are used in machine learning to learn from the data, and then accordingly they are giving us output. So supervised output can be either classification or regression. Unsupervised approach algorithm can be clustering, and reinforcement learning approach can give the decision making output. Fine. So as per the choice, as per our application, as per our objective, we can apply any one of the learning approach. Okay, if you want to uh, give your data to the model and that data is known to you, then supervised algorithm are used. Unsupervised, if we don't have the knowledge about the data, okay, so in that case we can apply the unsupervised learning. Fine. So let's consider one scenario regarding the unsupervised. I don't have the knowledge about that particular area. Okay, let's consider I'm visiting particular city, right? And I don't know about the knowledge of that new city. So I will just reach there, and I will just book the auto or whatever vehicles are there. Accordingly, I will reach at that particular location, because I don't know exactly how to go. So I will take the help of a data itself. Okay, so that not a data, I will take help of that model itself. Then in that case we can apply the unsupervised learning. Means if the user or the researcher who is trying to analyze the data is not having the knowledge about that data, in that case unsupervised algorithms can be used. Okay, hybrid, in some cases supervised are required, and in some cases unsupervised is also required. So combination of these two will be the semi-supervised or hybrid. Reinforcement learning to repeat some task. Okay, so in that case, if the tasks are repeated again and again, we can apply the reinforcement learning. Okay, like if you are trying to play some games, chess for example, so some activity, some movements can be repeated again, and accordingly model can learn from that movements. So in those cases reinforcement learning can be applied, right? Supervised, as discussed, two categories are there, like a classification, regression. Classification algorithms can be, WEKA is providing Navy based classifier, decision tree also, machine learning, support vector machines also, then random forest also, k neighbors also. All these are there, even though many more classification algorithms are there. Other regression, like a neural network regression, linear regression, support vector regression, decision tree regression, ridge regression, lasso regression, all these are the regression algorithms. Clustering K means, normally K means clustering is famous and which is applicable for some data. Main shift clustering, D, DBS scan clustering, right? Hierarchical clustering, Gaussian mixture, and here learning Q, R, and TD. So these methods are applied to the data for getting some output. Okay, if you are trying to get the output of a classification, then we need to apply these methods, naive Bayes or decision tree or support vector machine or random forest or k nearest neighbor or Bayesian networks, etc., etc. If you are trying to predict something, so regression can be applied. If you are trying to identify the unknown categories, clusterings are required, clustering algorithms are required. And if you are trying to make a decisions like which movement I supposed to do after some time, so in those cases, decision making algorithms are used. Fine. So that is the overview about the classification algorithms and the classification information. Hope so it is clear to all, right? So we'll take some questions. You can, if you have the question, you can just put your questions in the question answering section. Okay, so otherwise I will directly start the practical now. Is there any question? You can put your question in the question answer section. Is this clear to all? So, okay, if there is no question, then we can, okay, there is one question. Darpan Rokde sir is asking that can we classify the cyber data, means videos and photos, which is fake or which is real? Yes, of course we can uh, classify the data sets, like which image is a fake or which is a real, which video is a fake and which is a real, right? So that type of classification also we can do through the classification algorithms. Okay, but we have to check what type of data we are giving. If data is numerical format, if data is image format, then we can use here the WEKA, right? Other question? Okay, fine. So I'm just sharing my screen again. We will see the practicals now. Is my screen visible? Complete screen is visible. I'm opening the WEKA tool now. Is my screen visible? Window of WEKA. Can anyone confirm? Okay. So as discussed in earlier session also. Just open the WEKA software. Now practically we will apply the machine learning algorithms on some data, then we can get some output through this, right? Okay, thank you. Now see, just open your WEKA and then open the Explorer, which is here. Open the Explorer here. I'm clicking on Explorer. This new window is open now. The today's session is very important. So whatever activities we are trying to do, just do simultaneously whatever method, whatever approach we are following. So you will get some idea about like how can we apply the classification algorithms on different data sets, and then how can we get the output according to that data. Okay, yeah, fine. Now here I'm just opening my data. How to open the data? In a simple term, here four options are there. Just click on the first option where we will get our data set, where the WEKA software is installed. In that location only we will get the data. That is the by default data. Okay, external data also we can upload and use there. Yesterday I have shown how to download the data from the given sites, and then how can we upload here. For first demo, I will just take the by default data, and then for the next demo, we will take the another data. Just double click on your system's C drive, then open the program files, because under program files, WEKA tool is installed. Under this WEKA folder, we will get the information about the data. Double click on the folder, not on the name of the data, right? And these data are there. Okay, first of all, we will open weather data. Okay, that is already over. We have seen that weather data. We will apply the iris data, for example. Okay, you can apply any data according to the application. So I want to check the iris patients, iris characteristics. So that is why I am opening this one. Even though we can open the diabetic or any data as per need. Click open. Here numeric information is present. So there is no need to apply any filtering method here on the data, because the information is already filtered, means the data is clear. Because see here, no missing values are there. Data type is a numeric. Here numeric data type, no missing values, no missing values, unique numeric data type, and all. So here three type of categories are there of the data. Sorry, the classes. This is the last category. You know, as I discussed, last column will always be the uh, classes column, where our classes are present in the last column. So this iris data, 150 instances, I mean 150 rows are there, 5 columns are there, and here is the classification algorithm. Just click on that classification. I'm not doing any pre-processing here because already the data is uh, clear. No missing values are there. The format is also similar. That is why I'm not applying the pre-processing. Fine. Now here classification. Classifiers are present here. So choose on the classifier, click on that, and see why WEKA for classification. Because WEKA is giving all type of classification methods, all type of regression methods. Okay, Mo- uh, normal algorithms, simple algorithms to the advanced level algorithms are present in the WEKA tool. Okay, so traditional bias algorithms are there. You can see bias net, naive bias, multinomial text, updatable, bias updatable. So all these algorithms are there. Those are the traditional algorithms. Then some logistic function, multi-layer perceptron, simple logistic, SMO. Likewise, the function algorithms are there, regression algorithms are there. Then lazy algorithms are also there, like LBK, K star, LWL. Then meta classifier. This is a very important for advanced level classification. Meta classifier is one of the concept where we are trying to predict the output firstly from one algorithm. Okay, let's consider I am applying XYZ algorithm. So whatever prediction output I am getting from that XYZ algorithm will be added into the second algorithm's prediction. Getting my point? Means what? I have multiple models, I have multiple classifiers, and from those multiple classifiers, I will try to get their outputs, and lastly, I will combine the prediction outputs of all classifiers. Getting my point? Means, for example, I have three algorithms, okay, three different algorithms, and one algorithm is giving some prediction outcome, second algorithm is also giving the some prediction outcome, and third one is also giving some outcome. So outcome of all the three are added into one particular place, that is nothing but the meta classifier. So predicted output of different algorithms we can combine in a single phase to make a powerful model that is nothing but the meta classifiers. This approach is also known as a ensemble learning, so which produces some outcomes from multiple models, and then it provides some uh, meta classifiers. Okay, so under meta classifier category, so for advanced level of classification we can apply these algorithms. Okay, stacking algorithm, OAT algorithm, weighted instances handle wrapper algorithm, then the random subspace algorithm, then filter classifier, logi boost classifier, ADA boost M1, attribute selected, bagging, regression, classification via regression. Means see, firstly we are trying to use the regression algorithm, and then we are trying to classify from that regression, right? So combination of these two algorithms are there. CV parameter selection, then other classifiers. So these classifiers are there in the WEKA. That is why this tool is preferred by the researcher for analyzing their data. Here, serialized classifier, input mapped classifier is also there, but this is not frequently used. Rule-based classifiers. Some rules I will apply. Okay, rules like some rules will be built by the model, and then accordingly the model will be finalized, and we can get the output like a decision table. Okay, so class for building and using a simple decision table majority classifier. So this concept was given by the scientist, that is Ron Covey, in 1995. Then the second one is a JRIP. So this is also one of the rule-based classifier. Okay, here some rules are there, like first rule, second rule, building stage. Building stage is the first rule. Then the subset of first row is the grow phase, prune phase, optimization stage. So likewise, some steps, some rules we are following under these rule classifiers 0R. So that is the by default classifier whenever we open the WEKA and whenever we open the classifier menu. So 0R is one of the rule based algorithm using a 0R classifier. That type of rule mean or the mode of the nominal classes can be calculated under this, and then we can apply that one. Even though part algorithm is also one of the famous decision tree, sorry, rule based algorithm. And one more very important category which is given by the WEKA is trees. Very, very important. Trees and meta classifier. These two advanced uh, models are there in the WEKA. Decision stump, very important algorithm. Decision stump, then of heading tree, right? So this is also one of the powerful model based on decision trees. J48 class for generating the prune or unprune C4 data. So that is one of the powerful algorithm. Then LEMT, logistic model trees. Then random forest, very, very informative, very powerful algorithm for complex data. So it creates multiple decision trees, and according to the trees, it generates the output. Okay, so that is also one of the famous algorithm, random tree, and which is the fast algorithm, and last one is the REP, fast decision tree learner. Okay, so these models are there, by default models are there in the WEKA as per the data. I'm repeating the statement again and again because yesterday also, as per the data, we have to select the algorithm. So here we have the data of iris patient, and according to that iris patient data, we can apply any one of the models. See, by default is a 0R. Before applying the classifier model, we will take a break for 5 minutes, and after 5 minutes, we will continue with the practical. Okay. So after 5 minutes, we will join again. Welcome back again. Now we will see the exact method of classification. So here, as mentioned that we have uploaded the iris data. So we'll try to apply some model here on this data. So first of all, we will try one famous algorithm, that is a decision tree. Okay, tree-based algorithms, either decision tree or random forest or any one of the algorithm we can use here. Fine. But now I am applying this J48 algorithm. Which one? J48 algorithm under the trees. Okay, just select on that particular algorithm. First of all, load the data and click on this classifier J48. Click OK. Okay, so that algorithm is selected now. You can see some test options are present here because we have selected the model. So that model will learn from the data, from the given data. Okay, and now for testing the model, whatever model is applied here, for testing purposes we can use four options. Okay, four options are like a use training set. You can provide the training set, right? Then supply test if you have the testing data. Okay, so whatever training data you are having, you can put that data for the training, and the other data, if you want to test it, you can load from this one. So training data is one of the major option here for testing the model. Means whatever training data is given, apply that as it is. Supplied test set, if you are having the other test data, you can use this option. Click on a set and open either file or the URL. So whatever file or URL you want to open here, you can open. But right now we don't have the testing file. So that is why closing this one. Cross validation is also one of the famous method to test the model. Okay, so randomly it takes some value from the data and accordingly it tests the developed model. Okay, which model? Learn model, train model. So that train model will be tested through the class cross validation. That is the named as a tenfold cross validation algorithm. Okay, which is also one of the famous algorithm because it selects the value randomly from the data. Okay, whatever, for example, 10 values are there in the data. Okay, and from the 10 values, randomly this cross validation algorithm selects any one of the value, not only one, some values it will select randomly, and accordingly it will predict the output and it will test the data, right? Then fourth option is the percentage split. Okay, so here train on a percentage from the given data. We have given the data. In the data, 5 attributes and 150 instances are there. From this data, if I want to select some of the data, that is 66% data, for example, for training purposes, and for testing, reminder remaining data we can use. Means from 100% data, 66% data we are applying for training purpose, and remaining 34% we can use for testing purposes. Okay, so in this case, percentage split algorithm can be used if we don't have the other testing data set. We have the same data, and then from the same data we want to check the model. So in that case, some of the values from the same data we can use here, and then the remaining value we can use for testing purposes. So by default 66% for training only, yeah, not for the testing. You can just move cursor on this particular option. It will give the uh, overview of that option, like it will produce train on a percentage of data and test on the reminder. So 66% is it for training and remaining 34 will be for testing purposes. Okay, so this number we can change according to our preference. Okay, it can be 70-30, 70% also we can choose. Some will use 80%. Okay, not more than 80%. 80% is a, or 70% is a standard, or 66%, either 66, 70 or 80. From these three we can take any value and then we can apply the model. Fine. And after that you can see here more options are there. Okay, so we can apply any one of the option for testing it. Just now we will select the same percentage field, or we will see one by one all. First of all, we will see the percentage field. Click on more options. Here classify evaluation options are there. Output model, output model for training field. So that type of output, whenever we are checking on any particular option, so that output will be generated. Output per class set, output confusion matrix, entropy evaluation measure also we can produce here. Collect predictions for evaluation based on AUROC, receivers of curve, area under receivers of curve. So that type of information we can produce. Then error plot also we can produce, cost sensitive evaluation, and other information. Okay, so these are the some options. By default options are there. As per our requirement we can choose any one of the option, or we can select all or some of the options. Okay, so I'm not doing anything for this one now. Okay, and now see, I have selected the model. So now I will just click on this particular option. That particular a small window is there. We have selected on that window, and see the properties about the J48 algorithm. J48 algorithm is based on decision tree algorithm, which is one of the famous algorithm for numerical and nominal data sets. Okay, here you can see some of the information are there, right? So batch size is 100 of that model. Class for generating a prune or unpruned C4 algorithm. So there we can have these particular properties. You can see here. Just a minute. Yeah, binary split, collapse tree, and other information. So all these information are very important for us. So keep as it is right now, and click on OK. So I have not done anything here. I'm just putting the same setting as it is. Click on OK. Right. So I have just demonstrated the information of J48 algorithms and their properties. Fine. So there is nothing modified here. Keep as it is for this moment. And now here some options are there. What type of options? The attributes from the data. Those options are there. Okay. Just remember that. Select the last one. By default, it was the class option because we are trying to find out the uh, classes only. So that is why this last option is a suitable. Fine. By default, it was the last option. And now we can start it. Fine. So start the classification. Now see here at the bottom, status is OK. So that type of status will now change. Click on a start button. Result will be generated. Start to run your model. So I have selected J48. Click on this one and see within the second model has uh, built model has trained and given the output. You can see here at the right side, we have the output of our algorithm. So whatever options are selected here, according to those options, we have generated the output. Fine. So we will see first of all the information. J48 decision tree algorithm 0.45 M2, that algorithm we have selected. Under decision tree it was there, the J48, and the major J48 characteristics are like a 0.255 M2. So this algorithm is there. This is the relation, I mean the name of the data. Then how many instances were there, records were there, 150. Yeah. Attributes were 5. Yes, all these attributes are selected here. Test model, which mode we have selected for testing it, percentage field, right? So 66% data from the given input we have selected, and now the classification model full training set is given. So J48 prune tree algorithm is selected here. You can see some of the information is given. How many leaves were there for this algorithm? 5 leaves. Tree size is a 9. All the information is generated here as an output. Time taken to build the model only 0.0 second. Within the second the model is generated, and that model has given some output. And lastly, evaluation on a test speed. So this information is related to the training, the data, and now this remaining information from evaluation test speed. Okay, so this information is there for the remaining 34% testing data. Okay, so time taken to test the data 0 second. 0 second. Within the 0 second, the model is tested the information. Summary of the test information. Now, what is this exactly? We are trying to evaluate the model's performance. Here, according to this, you can see here our one of the point is building, evaluating, fine tuning classifiers in a WEKA. So create classifier, evaluate the classifier's performance. Through this, we are trying to find out the performance of the classifier. Classifier is nothing but the model. Okay. Now you can see here the performance of the model on a test data. Test data summary, correctly classified instances. How many classes are correctly correctly classified? 49 instances are correctly classified. Incorrectly, only 2. So total number of instances are 51. But in our original data, how many total values were there? 150 values were there, right? 150, you can see 150 instances are there in the original data. But from 150, 66% we have used for testing purposes. So means near about 100 values we have given for the training purposes, and remaining 51 values are given for the testing purposes. So according to the remaining 51, so we can predict the output, and then we can evaluate the output of the testing. From 51 correctly classified instances, records are 49. That means the model has given 96% accuracy. Correct classification accuracy is 96%. Only 2 classes are wrongly classified with the other classes. Okay, means 3%, near about 4% classes are wrongly given the output. Kappa statistics is one of the measurement which is also used for assessing, evaluating the performance of the model on a test data, and it is ranged between 0 and 1. Getting my point? 0 means the model has given low quality output, low performance, and near about 1 means the output given by the model is near to 100%. So you can categorize for the kappa statistic likewise. 0 means from 0%, 1 means 100%. So whatever values are there in between 0 to 1 can be matched with the uh, percentage. Okay, means for example, my value is 0.5 kappa value. I'm talking about the kappa statistic value 0.5. That means 50% correct output has been given by the model. That is the meaning of a kappa statistics output. In this case, the tested model has given 0.9408%, not a percent, values 0.9408 values have been given. Means the kappa statistics is saying that whatever results are generated by the model are 94% correct. Okay, so that is the meaning of a kappa. If kappa is greater than 75%, if kappa value, kappa statistics are greater than 0.755, that means your model is giving the highest performance. Okay, more than 9 means highest. You can categorize. There is a standard formula for this kappa, but normally 0.75 means the model is giving correct output. 5 to 75 means it is giving the moderate output, and below than 40 it is giving the low quality output. So that type of categorization we can do through the kappa statistics. So in this case, 94% instances are correctly classified. Some error is also there, mean absolute error 0.0396, that is the error. Root square, root mean square error is also there. Relative absolute errors are also there, and the percentage are given as per the means absolute error as well as a relative absolute error. Fine. So that is the classification accuracy. Now you can see each class's accuracy. How many classes are there? Three classes are there. Okay, how to check? Here you can see 1 2 3 three classes are there in the data, and according to three classes you can get the output for particular class. For first class, second class, third class, you can see first class, this is the for first class, this second is for the second class, you can see here. Then the remaining one is for the third class. Here also the class names have been given: Setosa, Iris, versicolor, then Virganica. Likewise, these three classes are there: Setosa, versicolor, Virganica. Okay. So for the first class, true positive rate, TP is nothing but the true positive. Means the correct output is 1.0, means 100% true positive rate is there for first class. False positive is a 0. That means nothing is wrongly classified for the first information. Precision, recall, F1 score, MCC score, ROC area, PRC area for the first class are 100% correct. As mentioned that 0 to 1, that is the range for getting our output. So accordingly 1 means 100%, 0 means 0%. Okay. Now for the second class, again see here, some of the classes are misclassified with each other, and that is why the precision is little bit low, which is 90%, you can say, or 0.990. Recall is a 1. F1 score is also 95, and other like a area under ROC curve, that is a 96% for the second class. Okay. Now see here, for third one, 88% is correctly classified with respect to the third class, and you can see the false error rate is 0, precision 1, recall is 88%, F1 score or F1 measure. These are the measurement metrics These are the evaluation measurements of the model. These are the metrics for calculating the output of the train model. Okay, so in data science, in the machine learning, in the data mining, for checking the quality of your model, for evaluating the model's performance, we can use all such type of measurements. So those measurements statistically we can calculate through some of the formulas, and according to the formula they generate some output. Okay, so these are the parameters through which we can identify the performance of the model. Whatever model we have applied here, that type of output we can generate here. And the weighted average for the all classes has generated here. That means 96% true positive rate is there, false positive rate is 0.023, and likewise all the values are there for all the classes. That is the average. Then last output is confusion matrix. Okay, confusion matrix is saying that it is one of the matrix. Okay, it generates some values according to the correctly classified instances as well as wrongly classified instances. Now see here, A, B, C are our three classes. That means Setosa is the first one, versicolor is a B, and Virginica is a C. These three classes are there. Okay, classified as ABC. A is correctly classified. How many values are there? Total 51 values are there. So in this matrix, you will get the total 55 one values only, because those values are used for testing purposes. So we are checking the performance of the model, whatever we have applied here, that is J48, through the confusion matrix also. Confusion matrix is saying that whatever diagonal values are there, okay, diagonal values like see 15, then the next one is a 19, and the third one is a 15. So these diagonal values means correctly classified instances according to, or you can say with respect to that particular class. So for A class, all values are correctly classified with the same class. Okay, A is one of the class. For that class, output generated by the confusion matrix is the same. Okay, so 15 are correctly classified. There is a no classification, misclassification with class A. Second one is a uh, you can see here names also given here. The B, this is misclassified with this one. Okay, so and the last one, okay, not this is not again misclassified. This last one is misclassified with a B. Means C output, C class is misclassified with a B. It should be 17. So 15, 19 and 17, we will get the output, that is a 51. Only two values are incorrectly classified. So you can see here only two values are incorrectly classified, and that can be checked through the confusion matrix. So such type of output of the particular algorithm based on particular data we can generate, and we can get and we can predict, classify the information as per our requirement. Fine. Now here I'm just taking the example of another test method. So second test method, for example, I am selecting, that is a cross validation. Okay, cross validation method. Here tenfold I am keeping as it is. Same values I am putting for this J48 because that value I have not changed here. Start it again, and now see, this algorithm has given some of the output. This is the training output. Testing method is a tenfold cross validation method. This is the tree generated by the algorithm because it is based on trees, right? Here we have selected the trees, and it has generated the trees. We will visualize the tree also. Just right click on this particular option and visualize the tree. Click on that, you will get the tree. You can see the tree. Petal width 50%, petal width here. According to that, this tree is generated by the algorithm. So we can copy this particular diagram and we can put in our reports or whatever research you are doing, right? And yeah, this model is evaluated and the answer is here. 46 correctly instances are there, and the model has taken all values. As mentioned, that cross validation is randomly taking the values from the complete data and accordingly it is trying to give the output. Okay, means complete data has been taken by the model and then it has generated the testing output according to this cross validation method. Means this model is given 96% correct accuracy, and this was also giving 96% 07, means the percentage split method has given little bit good accuracy. Okay, and yeah, other performances you can check here as per the particular class: true positive rate, false positive rate, precision, recall, F measure, and other classes, even though confusion matrix also. And the diagonal values you can see. First class is misclassified with the second class is misclassified with the third class is misclassified with the second class. So likewise, confusion matrix has shown the performance of the model, right? Third one, supply test set data. We don't have any data, so I am not using this one. Use training data. This third option I am using. Start it and see output based on the which model? Training data set. Test method is a training, means same data we are giving for the testing purposes also. Same data for training the model, same data is for testing the model. So in this case also, accuracy is only 98%. That means some of the values are there which are incorrect in the data. Okay, means in a data some of the errors are present. So that can be removed from the pre-processing methods. Okay. So from 150, 147 values are correctly classified with 98% accuracy. Means on the same data, if you are trying to apply the same testing algorithm, same data, so we can get the output with a 98% accuracy. And confusion matrix, only 1, 2, 3 instances are misclassified with each other. Like whereas B is misclassified with the C, and C is misclassified with a B. Okay. Now this is the first method I have applied on the same data. I will apply the second method now. Choose any one of the method. One method from trees we have selected. I will take from the Bayes theorem. Navy Bayes algorithm is one of the famous algorithm for predicting the values. Based on the predictors, based on the estimators, we can get the output. So that algorithm I have selected here. Where to select? From which model? Bayes. From this Bayes menu you can select it. Okay, and check the properties of this model. Just click here. Batch size and other information is given. I'm not changing anything for this moment. I'm keeping as it is. Close it. Now again check your model with this three test options. So first of all we will apply the training set. Start your model, means your model will run now. Okay, see the output generated by the model, that is Navy Bayes model, is the model is here and our output is here. Iris data is there, instances are there, test method is the training data, attributes. So this is the numerical data, mean, standard deviation, weight, precision, etc. All the information regarding all the classes, all three classes have been given here. So 0.33, 0.33, 33% information is given for all the classes, all the attributes, not classes, and accordingly the model has generated the result. Again, this model is giving 96% accuracy on a same data. So some of the information is wrongly classified here, and this type of information, this type of tables, we can use here in your papers and all. Okay. Second method, cross validation. For example, I'm just keeping as it is the by default settings. I'm not changing anything here because tenfold classification cross validation method is a very famous method, and that is used in the evaluating the model. Again, start the model navy base with the other. Same output has been given by the tenfold cross validation method also. 96% accuracy and 4% is the misclassified accuracy. Okay. So now last one, percentage sum of the data from original we will split into the training, and remaining 34% we will take as an testing data. Start your model. Yeah, see now. This is the summary. 48. How many testing values are there? 51, because from 150, 34% means 51 values have been taken by the model. So 94% accuracy has been given, and this is the, you can say, the correct accuracy, because either this method or this method, which is applicable and which is the correct method, because training set if we are choosing, so that is giving thus 96% accuracy, means we are giving the same data for training, and on the same data we are applying the testing method. And see, the cross validation method is also given 96%, right? Because you can see here the outcome of cross validation, and spilled data is used for testing purposes, and that 30% data whatever we have given for testing purpose has generated 94% accuracy. That means 94% values are correct and other values are incorrect from this algorithm. Okay. Now the next classifier I'm just using here from the other. Here, for example, I will apply the logistic regression. I'm keeping the by default setting as it is. From functions, logistic option I have selected. Okay, and you can see here some of the multinomial logistic regression information is given by the model. The mathematics, the probability about this model is given. So I'm clicking on that model. Again, I'm selecting the performances. I'm checking the performances. Now I will not select the use training set, because that is not giving the 100% accuracy again, because as mentioned that for same data we are applying the same for same data, training method is the same, and for testing method same data we are again applying. So either cross validation or percentage split. So that can be a suggested method for checking the accuracies of your model. So start it. See, 96% again from this cross validation. I'm applying the next one. Start it. 94%. That means logistic functions and navy base algorithms are giving the same output. Select the next model, check it, the performance. We have to select the best model. If model is giving 100% accuracy, then we have to stop it. Otherwise, we have to build new model again and again, and we have to test their performances. From a meta classifier, let's consider here the we can say bagging algorithm. This is one of the powerful algorithm for getting the desirable output from your complex data. Okay, so here we have just used normal data, but for complex data, as discussed, that Meta classifiers are very powerful because they get the output from multiple methods. Multiple prediction methods can be combined in a single classifier, and that meta classifier we can use for our data, and then we can get the output. Click on start. I'm applying last two methods now. Cross validation I will select firstly. Again, see, 94% accuracy is given. That means it is also not up to the mark. Percentage filled, start it. 96%. See, now we have applied four algorithms, and based on the performances of these four algorithms, you can see that still we are not getting the 99% accuracy or 100% accuracy on this data. Why? Because there is some minor error in the data. That can be the problem with the performance of these algorithms. Okay. Then feature selection methods we have not applied here. So as discussed that here in this particular task we are giving all complete features for the models, and we are generating some output. Okay, we have not cleaned the data because the data was clean as I discussed that, but still there are some errors in the data. That is why any one of the model is not giving the 100% accuracy. So we can again check with other model, or we can test the options with the different parameters. For example, here I will put 70% now, and I will try it. Now see, the accuracy is enhanced. Okay, so meta bagging classifier with the cross validation method has given 94%. Meta bagging classifier with the which algorithm? Test field. This percentage field, 66% data is training for training, and last remaining 34% is for testing. So it was giving 96, and then laterly we have changed the percentage. It is giving 95% accuracy. Again, we will check with this percentage. I am just adding 75%. Start. So again, low accuracy as compared to the earlier one. Add 80% for training and remaining 20% for testing. Check it again. Now see, the algorithm has given 100% accuracy. Okay, so testing is given on only 20%, and training for training purposes applied 100%. Sorry, not 100%, 80% values from the data. Okay, and 20 are given for testing, and based on those 20% values we are getting the 100% outcome. So there is no error in the the model. So this is the perfect model, you can say. Correctly classified 30, total are 30. So 30 classes are there, instances are there, all 30 are correctly classified with this algorithm. That means 100% accuracy has been given. You can say check the true positive rate is 1, that means 100%. False positive rate is 0, that means 0%. False positive rate is there. Precision is again 1, that means 100%. Recall is also 1, that is 100%. F1 measure or F measure, normally F1 score or F1 measure we can call, or in F1 or F measure also we can call. MCC, ROC, all are near to 1. That means 100% correct. And you can see the confusion matrix also. Diagonal values are showing the correct output according to the uh, classes. A class, how many values are there with respect to A? 11. So all are correctly classified. How many values are there for the B? 10. All are correctly classified, and remaining 9 are with respect to C, and those 9 are also correctly classified with the C. From total, all are correctly classified as per their properties, as per their classes, with 100% accuracy. So now we can say that this method based on this percentage split can give the better result. Okay, one more method I am applying here. Choose. So for example, rule base 0, it was 0R by default method. Now it was by default method, right? So 0R was the by default method. I'm trying to apply. I'm applying, for example, cross validation, tenfold cross validation method for testing the performance. Start, and accuracy is only 33%. That means this model is not suitable at all for this data. Okay, percentage split again by default 66% I am keeping, and starting the model, and see accuracy is only 29%. That means 0R classifier is not suitable for this data. So as discussed that whatever data you are having, according to the data, according to the property of the data, you need to apply the models, because in this data numerical values are present. You can see numerical values. Data type is a numerical. Okay. So that is why this 0R rule based algorithm is not applicable. This is the rule based algorithm that is not applicable for this one. Miss again, yeah. So that is the story about classification algorithms. I hope so you have gained some knowledge about this one. So quickly I will add another data and I will apply any one of the method here for a quick overview of the today's session. So open the new file. Okay, so here I will add another data, that is a diabetic data, for example. Open, because in this data the instances are more and the attributes are also more. I'm applying the classification method directly. So let's consider here the meta classifier or the J48 classifier. Why I am selecting J48? Because for complex data J48 is a suitable algorithm and it gives the correct output. So that is why J48 algorithm I am selecting again and again. As mentioned that key whatever algorithms are there, so as per our datasets requirement, we need to apply any one of the algorithm. Okay, and the algorithms performances, whatever performances are there with respect to algorithm and their working strategy of that algorithm, how the algorithms works mathematically, we have to understand that firstly, and then we can apply those model. Okay, so if you want to apply any one of the model, just try to learn the background of the model, the theory of the model, the mathematics behind the model, and for what type of data the model can be suitable. Understand such type of functions of models firstly, and then apply model on your data. That is the suggestion for applying the algorithms. J48 I have selected. Cross validation I am applying for this data. 73% accuracy is given by the cross validation. Using training set, again we'll apply the start 84%. That is little bit okay. Percentage split, run it 76%. You can change the values from here. I will put 80 20. 80 is for training purpose, 20 is for testing purpose. Click on this 70%. So this model is not giving the correct outcome because again I am discussing here might be some errors are there in the data. Some errors are there in the data, so that is why this model is not giving the correct output. Fine, so that should be renovated from the filtering methods, or you can apply the feature selection algorithms and then we can select the best suitable features. We can avoid the incorrect features and then you can apply any one of the model. Fine, so that is the summary about the algorithms. Hope so you have gained some knowledge through the algorithms. Okay, now the session is open for question answering. You can ask the question, you can put your questions in the chat box, so we can try to give the output, sorry, outcome. So I'm just putting the link here, attendance link I have received. Yeah, I think it is given. In this chat box also I am giving the attendance. Put your attendance. Is there any question? Is there any question to anyone? How to decide that we have to apply filtration process is needed before classification? So Darpan Professor is asking the question on this. How to decide whether, how to decide that we have to apply filtration process is needed before or not? So as discussed, we have to firstly open load the data. So in this case, you can just use this particular option under this menu. You can visualize the attributes from this one, and you can check whether there are some missing values, whether the data is correct or not. Or here, through this also we can check the patterns, sorry, we can check the models and their unique values. Only 8 unique values are there from the 47. Okay, means total 47 values are there in this particular attribute, and only 8 values are unique. What about the remaining 39? So those 39 are, might be incorrect values, might be missing values. Not missing, missing values are 0, might be incorrect. Maybe they are having some error, maybe they are having some other formats. So likewise, we need to check firstly, and then we can apply the filtering methods on the data, and we can renovate it. Okay. uh, okay, so I am putting the attendance also here in the chat box. In the chat box I have given the attendance. Just put your attendance here. Shruti Khandelwal madam is asking that, sir, can we cannot see the chart, please put the attendance link on WhatsApp. Okay, Shruti, do one thing, just put your attendance on YouTube link, so there they will monitor it. Okay, so they will take a record of the attendance, because yesterday it was discussed that key attendance need to be closed within the timing. Attendance will open only for 15 minutes. Okay, so before the closing time, you have to just mark your attendance either through this link or through the YouTube. Okay, so there they will take a snapshot of your attendance, and accordingly they will mark it. Okay, so I am putting attendance here also. Check it. I have added the attendance in the question answering section also. You can just check it. Is it there now? Can anyone let me know whether the attendance is there or not? Kunal, attendance is given in the question answering panel. Just take it again. Okay. So now we can have the attendance here in the question answering section. So I tried with Zoom also, but there is a limitation with Zoom. So it runs only for 40 minutes. So that is why this particular platform is selected. Okay, so attendance will be open only for 10 to 15 minutes because here you can see some of the attendees are joining here and they are receiving the count of more than 200, right? So that is why they said that attendance must be monitored within the 15 or 20 minutes. Dhaval sir, do you have any question? You can put your question in the question answering section, so I will try to answer it. Is there any question? If there is no question, uh, we can say that the today's session is over. Tomorrow we will see the unsupervised methods. Okay. So thank you so much for joining this session. Have a good day. Thank you. Bye bye.